In this video, I'm going to show you how to use a binomial probability distribution and do application problems. We're going to start with this question. A poll reported that 64% of adults were satisfied with the services of their internet service provider. Suppose that, so 64% is called the probability of success. The probability of failure will be 100% minus 64%, which is 36%. Suppose that 15 adults are selected at random and the number who are satisfied is recorded. Complete parts A through G below. Explain why this is a binomial experiment. Well, a binomial experiment has to meet some guidelines or conditions. The first condition that the experiment has to be done a fixed number of times. And here we are surveying only 15 adults, so we're doing the experiment 15 times. We're asking 15 people, so that's fixed number of trials. Second, there should be only two outcomes. So when you survey the person, the customer, he or she is going to say either they are satisfied or not satisfied with the service. So there is a probability of success and probability of failure, only two outcomes. You either answer, yes, I am satisfied, no, I'm not satisfied, which is the case here. And the third condition is the probability of success does not change from one customer to another. And here we say the probability of success is always 64%. The chance that you ask a person whether they are satisfied or not with their internet service and they say they are satisfied, the chance is only 64%, and that does not change. So the three conditions are met, and thus this experiment is a binomial experiment. So let me display. Sorry, let me just do that here. And let's select the font. And one more thing I would like to add here. What are the possible values of the random variable x? Well, if you survey 15 adults, it is possible that 0 adults, 0 of them will say that they're satisfied, with the internet service, or 1, or 2, or 3, or 4, or 5, all the way up to 15. So x takes the values from 0 all the way to 15. Always x will be as low as 0, as high as the number of trials, which is in our case is 15. Second question. Find the probability that exactly 10 of them are satisfied with internet service provider. So if you survey 15 people, what's the probability that only 10 of them are satisfied with the internet service provider? There are two ways to do this. You can do it using a formula by hand, which I'm not going to touch on that. We're going to use technology. So either we're going to do that using TI-84 or StatCrunch. I'm going to show you first of all how to do it using TI-84. So we need a probability. Let me show you what I've written here. Okay, so you write probability of x equals 10. Which is equal. Okay, and I want to bring the calculator up and show you the formula that you will use when he asks you to find the probability that exactly a number of them is satisfied, which is in our case is 10. So turn the calculator on, you go to you go to second. Sorry, let me clear this. Let me clear this one. So press second and variables, and then you go scroll down, binomial PDF. So the binomial PDF is reserved for the question about exact number. So enter. Okay, how many trials we have? We have 15. We ask 15 customers. What is the probability of success? It's 0.64. And what's the question? What is the value in the question? Is 10. And then paste, and then press enter. and it's 0.2093. Okay, now how do you interpret this answer? Let me give you a possible interpretation of this answer. Like if you do 100 surveys of 15 customers, if you take 0.2093 of 100, which is about 21 surveys, in 21 survey, you're going to find out that exactly 10 out of 15 customers said that they are satisfied with the internet service provider. Okay, going back to the calculator, let's say I ask you what's the probability that none of them is satisfied with the internet service provider. Here's what you can do. Again, I'm going to scroll down to A, and none of them means x equals 0, guys. You just put x equals 0, and then here you go. Well, E minus 7 means you have to move the decimal point 7 digits to the left, so it's going to be 0.00000002, which is a very low probability. So it seems like it's not going to happen that you ask 15 customers and all of them say that they're not satisfied with the internet service provider. It's not going to happen. What about if I ask you that the probability that all of the customers are satisfied with the internet service provider? So if you go to second distribute, you go to binomial PDF, and you should guess what we're going to replace x with now. All of them means all 15. So x will be 15. And x, I don't think this is going to happen that all of them will say that they are satisfied. So watch. The chance is 0.0012. It's a very low probability as well. If I ask what's the probability that exactly 7 of them, so you just replace 15 by 7. Actually, guys, there is a way to find the probability of x equals 0, probability of x equal 1, 2, 3, 4, all the way to 15 in one shot. And let me show you how to do that. Look what I did here. I went to stat edit. I put L1, the values of the random variable. So I went from 0 all the way, as you can see, to 15. So I put up to 15. Then I'm going to go to second and distribute. I'm going to go to binomial PDF. I'm going to put trial is 15. Probability of success 0.64, never change. And look what the x value I'm going to put here. I'm going to put L1. And you know what the calculator is going to do now? It's going to give me probability of x equals 0, x equal 1, x equal 2, x equal 3, all the way to 15. Watch. Paste. Oops, it did it here. So let me clear here. We don't want to do it here, so I'm going to do it one more time. Do it. We didn't do anything wrong, but the output wasn't going to be displayed in the right place. All right, and watch, guys. There you go. These are all the values. Watch, you can scroll to the right. This is probability of x equal 2. This is probability of x equal 3. X equal 4, x equal 5, x equals 6, x equals 7, x equals 8, 9, 10. You see the 10 right there, 0.2093, which we did already. The next one is probability of x equal 11. Then the probability of x equal 12, 13, 14. And remember the 15 was 0.002. There you go. You're going to see the last one, 0012. These are all the probabilities. You can find them all in one shot using the calculator. How can we use StatCrunch to do this one? So I'm going to open StatCrunch and show you how to do this. Okay, for StatCrunch, you go to Stat, Calculator, Binomial, and here you go. You provide the value of n, which is 15 in this question, and you provide the probability of success, which is 0.64. You're going to find using StatCrunch, it's very straightforward here. And what is it that we want? We want the probability of x equals 10. You select, click here, and equals, and then you put 10 here. and compute, and look guys, 0.2093, and that's the answer that we got earlier. And see, it marks in red what we're looking for. This is exactly probability of x equals 10. This is 9, this is 8, 7, 6, 5, 4. You don't see the 3, 2, 1, 0 because they're very, very small that they don't even show here. There is no bar. And that's how you do it using a stat crunch. So let's go to the next question. Find and interpret the probability that at least 10 of them are satisfied with their internet service provider. Okay, I'm going to show you how to do this using StatCrunch first. So 0.64 for the internet probability of success, and you have to put the 15 here. Okay, at least, guys, means greater than or equal to. So you just use greater than or equal to, more than 10, and compute. And look, at least 10 means 10 or 11 or 12 or 13 or 14 or 15. What the calculator did, it found the probability of each one and then add them up. And here's the answer, which is 0.5316. Okay, so that's how we can use StatCrunch. All you need to know, guys, is what at least sign means. At least means greater than or equal to. There is a way to do it in using TI-84, which I'm going to show you how to do that next. Okay, if you want to do this using the calculator, I don't suggest that you do a formula by hand at all. If you want to use the calculator, he wants at least 10 of them. At least 10, guys, means 10 or 11 or 12 or 13 or 14 or 15. There is no formula on the calculator that does at least, but there is a built-in formula on the calculator that does at most. Well, if you guys look at the numbers 9 all the way down to 0, these are the ones that we don't want. But we want 10, 11, 12, 13, 14, 15. But if you look at the numbers from 9 and below, that means it's at most 9. If you want to write it down, it means at most 9. And as I told you, the calculator has a formula that does at most. So here's what I'm going to do. We're going to do the probability of at most 9, which means 9 or 8 or 7 or 6 or 5 or 4 or 3 or 2 or 1 or 0. And then the answer that we get, we subtract from 1 because the sum of all probabilities must equal to 1. So here's what I did here. Probability of x greater than or equal to 10 equals 1 minus probability of x less than or equal to 9. And then probability of x less than or equal to 9, guys, you can do it using this formula, which is called binomial CDF. Not the PDF, just like we used before. The PDF is reserved for equal. For at most, we use CDF, cumulative density function. So I put 15, I put 0.649, and then the answer I get, I subtract from 1. And let me show you on the calculator how we can do that. I'm going to bring the calculator up. Okay. Second and variable, distribute. And we're going to go to binomial CDF. Trial is what? How many? 15. Those don't change, never. 0.64 is probability of success. And the x value is 9. So what the calculator is going to give me now, probability of x equal 9, 8, 7, 6, 4, 5, 4, 3, 2, 1, 0. And then paste. Okay. So it's 0.4684, but I don't want this. I want the other one. So I do 1 minus 0.4684. And that will be your answer. You can subtract this. 1 minus 0.4684. And that should give you 0.5316. Okay. D. Now, how do you interpret this? if you want to interpret this, so out of 100 survey, you're gonna find out that out of 100 survey, this is 53. In 50, take 0.53 of 100, so 53. In 53 of the surveys, you're gonna find out that at least 10 of the customers say that they were satisfied with the internet service provider. Part D. Find and interpret the probability that between 11 and 14 of them inclusive are satisfied with the internet service provider. So between 11 and 14 inclusive means 11 or 12 or 13 or 14. You can do, guys, probability of X equal 11 using binomial PDF, then do 12, then do 13, then do 14 and add them up if you use your calculator. But if you use static range, let me show you how to. Okay, here's the binomial calculator. I use in between here, and I put 11, and I put 14, and let the calculator do it, and that's the answer. That's 11, that's 12, that's 13, that's 14. What the calculator did, it added all the 4 probabilities, and they add up to 0.320321. Okay. And if I show you how to do that using the TI-84, you can do this. Then you find the probability of X equal 11, probability of X equal 12, probability of X equal 13, probability of X equals 14, and then add them up. Or if you use a static range, we already have the answer. E, would it be unusual to find that more than 9 customers out of the 15 surveys are satisfied with their internet service provider? Unusual means the probability is less than 5%. If the probability is less than 5%, then it is an unusual event. If it is 5% or more, then it's not unusual. So what I need to do, guys, is find a probability of X greater than 9. And how we're going to do that? If we go to static range, let me show you. More than 9 means greater than 9. Greater than 9 means 10 customers, 11, 12, 13, 14, 15. You can do probability of X equal 10, and then 11, and then 12, and then 13, then 14, then 15 using the binomial PDF and add them up. Or you can use static range here, guys, in one shot. Watch. So I'm going to go to standard again. We need more than 9. And compute, and look, the calculator did 10, 11, 12, 13, 14, 15, add them up for me, and that's the answer, 0.5316. Okay, now I'm going to show you how you could have done that using the TI-84. Okay, more than 9, guys, means 10 or 11 or 12 or 13 or 14 or 15. The calculator doesn't have a formula to find more than, but it has a way to find at most. Well, look, 10, 11, 12, 13, 14, 15, that's what we want. But what we don't want is 9 and less. And 9 and less, guys, means at most 9, and we already done that in part C. So we already know the answer for this one. We did binomial CDF 15 0.649, and we got the answer subtracted from 1, which is 0.5316. So the probability here of X more than 9 is 0.5316. Do you think this is unusual? No, it's not unusual, because this probability is more than 5%. It's 53%. Okay. Now, if we ask you what's the mean and the standard deviation of the binomial distribution, there is a formula you need to use. The mean of the binomial distribution, or the expected value, it's called NP. And to find N is 15, and P is 0.64. You just multiply the two. There is no built-in formula on the calculator to do this. You can simply do it by hand. And if I bring the calculator up, turn it on, and put 15 times 0.64 I get 9.6, and that's the answer for this. Now we need to find the standard deviation of the binomial distribution. The standard deviation, guys, it's square root of npq. Q is the probability of failure, which is 1 minus p. So if we want to do this, that will be equal square root, n is 15, p is 0.64, and 1 minus p is 1 minus 0.64. Okay, and now if you bring your calculator back up, 15 times 0.64 times 1 minus 0.64 equal, and then I need the square root. To find the square root, raise it to the power of 0.5, which is 1.859. If he asks you to find the variance of the binomial distribution, will be sigma squared, so you don't do the square root. It will be 15 times 0.64 times 1 minus 0.64. What is the probability that at most 5 customers are satisfied with internet service? At most, guys, there is a built-in formula for that on the calculator, which is the binom CDF. So at most, you can write it x less than or equal to 5, which is binomial CDF, 15, 0.64, and then put 5. What's CDF here? What the calculator is going to do is going to find the probability of x equals 5, and then 4, and then 3, and then 2, and then 1, and then 0, and add them up. But it's all done in one shot here. So let me just bring the calculator back up. And second, variable. And then I'm going to show you how to do static range for this one one more time. So all I need to change the 9 to 5 here. And the answer is 0.0154. And if you want to use a static range, guys, just change this one to less than or equal. I should get the exact same answer. Watch, 0.0154. And you see it did the 5, the 4. What you see highlighted in red are the ones that being added and calculated. So this is pretty much what you need to know about binomial distribution.